So let's talk about the system internally a little bit, just so we kind of get a clear understanding why our code might not correctly work. What I mean by this is one of the major errors I would see my students getting is they won't be using the IntelliSense. Again, IntelliSense is this thing that pops out as you write out letters, right? And if there's nothing, it'll just give you an red. Otherwise, it'll bring up this thing and you could start typing more to get a more defined or specific answer, like short. And we could just select it and we'll autocomplete. Now, you might have written system, but you'll notice that the IntelliSense is not showing it to you. Or you might have written it out completely and you notice that there's a big red message. And you're like wondering, why is that there while I wrote the same thing? Well, the thing is, you haven't written the same thing. If you notice, we forgot to capitalize the S. But come on, that's the same exact thing. Who cares, right? But the problem is that the computer is really stupid. We could understand that capital letter and lowercase letter, they mean the same thing. But inside the compiler, inside Java, or many languages actually, when you compile the code into binary, into something that the computer understands, it doesn't actually see capital letter S or lowercase s, it sees something completely different. Let's see what that thing is and try to understand why these two things are so different. And then that matters that we write our code properly. And if we make a spelling mistake or if we forget a capital or a lower or an etc., it will just break everything, right? So let's go a quick overview, really short and simple, so I might be leaving some stuff out. Take it with a grain of salt. Now, when computers got invented, let's say, they figured out we could manipulate electricity, right? Electricity. Hopefully, I'm drawing something maybe like this. So electricity is really powerful. It's really useful, and inside our computer, they could send information from one part to the next by sending this electricity there. And by different types of manipulation, they could make it into some sort of Morse code. So if I cut the power, let's say if I send power and then I cut off power and then I send power again, or I cut off for longer or I send for longer, we could determine, so you see here, this is on, this is off. We could determine what the message is coming in. The same thing as Morse code, right? So sending power and turning it off, we could figure out like this is a 1, this is a 0, as an example. On, off, etc. Or we could even use time rather than doing on, off all the time. We could say every interval of 1 second, right? We get some code, right? Every interval of 1 second, we know what the message is. So we got 1, 1, 0, 1, 0, 0, 1, 1. Okay, so they utilize this power, this type of communication, to send information to different parts of their computer. Now, go one step further, they needed to keep that information stored inside the computer, right? Inside the storage, inside the memory. Now, how they do it, we're not going to go into details, but again, what they're going to do is use some sort of, let's say, magnets as an example, to turn on some of these little switches, okay, as an example. And the same thing we did for this communication, all of these switches that are turned on could represent something. So 1, 0, 1, 0, etc. So in the base of everything, it's all about electricity. And because this electricity we could only do on and off, they wrote the whole computer knowledge, or let's say the language of the computer, into this thing we call binary. Okay, and again, I'm simplifying a lot of this stuff, which if we go in more details, would be a bit more different, okay? But I'm simplifying it. So knowing that everything is going to be this electricity 1 0 and 1 zeros, right? Um, they started figuring some ways to make this into more of a human language. So we got the computer language. And what we're trying to do is reach the human language, or as close as possible. And over the years, we're getting there closer and closer. And you'll notice at the top, this is why Python is it's so loved. It's really close to being a human language. You write one thing, it does all the code for you, all the stuff for you. But to get there, like let's say as an example, Python is written on something like C and C++. So it's actually, this is getting converted into C and C++, and that is getting converted into this binary language, ones and zeros, right? And there's a lot of different things in between, like Java is over here, it's a bit high. And again, the same thing. Java was actually built on C and C++ back in the day. Might be a bit different now. Who cares? Doesn't matter. But there's a lot of different levels. And whatever goes up, so the stuff that we're seeing here, all the stuff that we wrote here, for us to be able to run our application, we need to go back downwards onto the compiler language. Okay? Now, how do we go up? This is the first initial statement. How can we make these ones and zeros show us the letter S, or the lower letter S? How do we show this stuff? Well, that's pretty simple. What we're doing there, let me pick maybe something other than pink. What we're doing there is we're saying the sequence of these numbers could represent a number. So let's say, as an example, we got 0, 0, 0. This is all binary. Remember that binary only has the values of 1 and 0. Okay, so we stored all of these binaries somehow, somewhere. We don't need to know that too much. And it keeps on going. And we said, if all of them are turned off, well, that equals to 0. If the first one is turned on, but everything else is turned off, well, that would equal to 1. Right? Now, we can't have any other numbers than zeros and 1 because it's all electricity. So if we add another 1, this one becomes 1. This becomes back to 0. And we keep on going. This is 2. If I turn on another one again, starting always from the right, this is equal 3. If I add another one, well, this becomes 0. I add another one here, it becomes 0. I add another one here, so it becomes 4. So you could see that the sequence of this binary, of these zeros and ones, determines what we're going to be showing inside the screen. So the screen will display whatever that sequence for that location is being given. Right? And we could do that again further for the same thing for letters. So let's say, as an example, we keep on going and eventually we reach, let's say, this one. And this would be our first letter, A. But something to note is that this is a specific sequence representing capital letter A. This does not represent two different values. It's one sequence for one specific value. So if we wanted the lowercase letter A, well, we need to create another sequence, maybe like this. Okay? So understanding that these sequences are turning into the specific letters tells us a lot, because for us to get from the computer language to the human language, we need to change these binaries to something that we could read and understand, right? Reading all these zeros and ones it's disastrous. It will blind you forever, right? So for us not to get blinded, we want to convert these binaries into a human language. And that's what we're doing, right? Now the problem comes in is when we got our Java code and we written our Java code, let's go change a different color. When we written our Java code and now we wanted to compile it and make it into something runnable, we need to go back down that path we came. We need to make this Java code into a more computer language. Okay, we're skipping some details, but we want to go back downwards. Well, all of this needs to be converted back into these binaries. And if we look over here, the capital letter S is not the same thing as the lower level, the not capital letter S, right? These are going to be two different binaries. So when the system is trying to see this sequence, well, it can't find this sequence because one of the binaries has a completely different value than what I normally have. So this is why we get this big red here saying, I can't find this thing, even though it's the same letter. But in our case, the capitalization matters, which character we use matters. So really, one thing you should get from this is that our computers are really stupid and we need to be specific. We need to make sure on our end we don't make any of these types of errors. Okay? And this will allow it to compile when you press this play button. So this will compile the code so that it could be executed for you. All right? I hope you learned something. If you have questions, let me know. I'll see you guys in the next video.